record this so we can put it up so we have all three techniques. So Venn diagrams are used when we come up and we have an overlapping section. You know that this and this are probability that occurs a certain way, right? So when you see that it's a joint outcome, that means you need to draw your Venn diagram. You set it up so that you have your two categories. In this case, it's soccer and it's Latino. You fill in the both section first. Okay, that's the easiest place to start. And then you're going to, for each circle, you fill in the remaining part by subtracting the both from each probability that you have. And that gives me each section. Okay? Then I add all three numbers together, all three of these, and I subtract from 1 to get what's outside the circles. That's a really important concept. Okay? You may not use all those, but at least you have an idea of how to get them all. Right? And so in this case, what's the probability of not being a soccer player and not being a Latino would be, you add them all up, subtract it from 1, gives you 0.59. Questions? One of those is true, but not both.
It's not hard, but it is multiple choice, or it's hard.
It's not multiple choice.
So that means it's not hard. Oh, this question though. Wait,
Here we go.
Wait,
Number 32. Shh. Here we go. The question says, you have a couple things. A poll of 120 Ithacans found that 30 visited the Museum of Earth, 80 had been to the Home Depot, and if it appeared that going to Home Depot and going to the Museum of Earth were independent. Listen carefully. They're not just telling you that because it's just good to know that. They're telling you that because if I know that it's independent, what does that allow me to do? That's exactly right. If I know that it's independent, then what we can do is this. P of A times P of B is going to be equal to P of A and B. So if they're independent, and if I know the probability of one, the probability of the other, then I can just take those things and multiply them together to figure out the probability of both of them happening. Okay, let's keep going. It says, how many of those polled had been to both? Now, this one's different than previously. I've been asking you about probabilities. What am I asking you to answer here? What kind of risk? It's a number of people.
30.
So if I knew the percentage of people that went to both, couldn't I, if I know how many went total, right? Shh, listen. If I know that if there was 120 people that went total, then if I knew the percentage of that 120, then I would know exactly how many people went. So we need to figure out the percentage of people that went, or the probability, right? So let's look at our Venn diagram. We're looking at let's let A be our Home Depot people, and we'll let B be the museum. What's the probability or the percentage of people that went to Home Depot out of my 120 people? You're right. Okay. At a Home Depot, we had 80 go. What is the probability or the percentage of museum people? How many people went to the museum?
30.
30 out of 120. So if they're independent, then I can just multiply this together, right?
No. If they were independent, what would you have to do?
What's the multiplication rule for dependent events?
I wish I did.
Yeah, I wish you knew too.
What is the what?
You would add them and then...
No, you're going to get something confused. Watch. It's probability of A. This is for dependent. For A and B, it's going to be equal to the probability of A times the probability of B given A. Remember the cards? If you draw two cards at once, then the probability of getting an ace both times. If I give you that one card and it's an ace, then the probability of getting the card the second time has changed. So it's 3 aces left out of 51 cards. So that would be for dependent events. But I don't need that now, right? Because that Doesn't apply. It's easier than that. Shh. What's the probability here?
Probability.
Can you multiply that together, guys?
And then equals 1.16.
We know that it equals about 16 2/3%, right? Oh my gosh. Don't say that. Okay? The question is, shh, listen. I'm telling you the percentage of people that went to both. Can you tell me how many people went to both?
1.120 equals 120.
Good. 0.1667 times 120 people. That's equal to 20.
Are you going to give us partial credit on stuff?
Of course, always.
So like assuming I got all the way to the 0.6.
Bree, look right here. 120 people was the total number of people that went to the whole event. Total of the table is how many people, period. So if I have the total of the table, I wanted to know the percent. Well, I wanted to know how many people went to both places. But I don't know because the table is empty. But I can tell you the percentage of people that went. So if you tell me the percentage, if 16.67% went, and I told you how many people that went there total.
Does that mean that? So you would put 20 in that box?
Yeah, 20 goes in the question mark box. But that's the answer to the question. How many people went to both?
Wait, that makes more sense.
Where is the 0.1667? Where's that?
I took the percentage of people that went to Home Depot times the percentage of people that went to the museum. And when I multiply those together, it tells me the percentage of people that went to both.
Or Ithaca.
I think the city is like Ithaca. That's what I thought. But I don't think there's a Home Depot up there, is there? I don't know. It doesn't matter. It doesn't matter. Shh.
What's the probability that there is a Home Depot?
That's a good question. Let's move on. Shh. I want to do 35, then I'll come back to 33 and 34. 35 is a basic tree diagram. And so we've got this situation. Surveys indicate that 5% of students who took the SATs enrolled in the SAT prep course. 30% of the students were admitted their first choice for college, as were 20% of the other students. You overhear a classmate saying that he got into a college that he wanted. What's the probability that he didn't take an SAT prep course? Okay? So somebody walk me through it.
Okay, the first thing you take a class or not? Yeah.
Okay, so
SAT class? No, SAT class. So, right, yes.
so SAT and then not.
What? SAT prep class. And that would be 0.05, right? Because 5% of students took the SAT.
So what would be for no?
0.95?
0.95.
Wait, is that, am I right?
Yes. So far, remember every time you split that stem, you've got to sum to 1. Right? So if I look at just the SAT prep group, so we have a group that got into their first choice. So we'll write first, okay, and then not.
And then,
So what's the probability that you got into your first choice?
if you took the SAT prep,
Yes.
30%.
So 0.3, and then this will be 0.7. Let's go down to the next part. If you did not take an SAT prep course, 20% still got into the college of choice, and 80% did not. So this will be first, and then not. So let's back up and let's write out what the question is asking. Remember, I think everybody's got a good handle on making these diagrams, but the question comes, okay, so what do I do with it? So write out the probability. What is it? Probability that you what?
Got into the first college.
No prep,
No prep given first college.
first choice. Because it said, he said, I got into my first, right? I got into my... What's the question at the end says, what is the probability he didn't take a prep course? So that's the first thing that comes. So you're going to look at all the students that got into the first choice, and out of that total, you want to know the probability that he was in the no prep group.
Is it 0.3?
So where's the first choices, right? It will be here, and it would be here. So I'm going to have to go in and find those probabilities. So how do you get the probability?
0.05.
Multiply down that line. So the first one is going to be what?
0.015.
So that's going to be equal to 0.015. So this is equal to 0.19. We've multiplied, we followed the path down the line. We multiplied these two values together to get these numbers. Right? So 0.05 times 0.1 or 0.3 to get this. These two numbers, when I add them together, it says that I got into my first choice college. That's the total percentage that got in.
So you multiply this together and then divide by the sum?
No. Well, I'm going to add them together. So I'm going to have 0.015 plus 0.19 to give me right. So basically 20.5% of the people, period, got into the college of their first choice.
So is that the denominator?
That is the denominator.
And then 0.19 on the top?
Yep. So people that didn't go to college or didn't go to a prep course, we said it's 0.119 divided by 0.205, which gives me approximately 93%.